All right, these are the notes for section 7.2. And section 7.2 is very, very similar to section 7.1. The only difference is they're actually going to tell you the answer from the beginning. You just need to show the steps from how you're going to change one side of the equation to get to the other side. We've talked about some strategies for how to do that, and your book has a really nice list of strategies that are great for simplifying expressions. And why don't you take a minute and write those strategies down in your notes. Pause the video to write down those strategies, and then we will talk about them together and what they mean. All right, at this point, you should have had a chance to write down those 5 bullet points, and let's talk about them one by one. The first one, transform the more complicated side of the equation to the simpler side. As you're doing these problems, you're going to have 2 sides to the equation, and you're only allowed to work on one side, and you have to stay on that side the entire time until it equals the other side. And the strategy here is you always want to start on the more complicated side and make it look like the simpler side. So that's how you pick which side you're going to use. Substitute one or more basic trig identities to simplify expressions. That's basically saying change everything to sines and cosines, and or use the trig identities. Use the sine squared plus cosine squared equals 1, and the other 2 Pythagorean identities that we get. Oh, and I meant Pythagorean identities here. Pythagorean identities. The third strategy we talked about in the 7.1 notes, which is to factor out common terms. That works really well. Multiplying expressions by an expression equal to 1. We're going to use this a lot of times when we have fractions. And what that is going to look like is if we have a fraction in a fraction, we're going to flip and multiply by the reciprocal. And since we're multiplying by the reciprocal on the top and the reciprocal on the bottom, we're really multiplying the entire thing by something equal to 1, because we're multiplying the top and the bottom by the same thing. Express all trig functions in terms of sines and cosines. That one's a very popular one that we're going to use a lot as we go through these. So these 7.2 notes, they're just like the 7.1 notes, except for they give you the answer from the beginning. And here's what I mean. Here's an example. Verify that secant squared minus tangent x times cotangent x equals tangent squared x is an identity. So what I mean by they're giving you the answer is in 7.1 they would have just given you this side and said simplify. Now they're telling you what it's supposed to simplify to, and you've just got to show your work and show how it happens. We always want to start with the more complicated side and make it look like the simpler side. So in this case, the more complicated side is the left side of the equation. And we're going to try to take that side and make it look like the other side. As we do that, we're going to use some of the identities that we have. And one thing that we can do is change everything into sines and cosines. In one of the cases here, we're going to end up undoing what we're about to do. But let's just start with changing everything into sines and cosines from the beginning. Secant squared x is the same as 1 over cosine squared x. Tangent is the same as sine over cosine. And cotangent is the same as cosine over sine. Now you have to be careful with your fractions because we have subtracting fractions and multiplying fractions in the same problem. So when we're canceling things out, we're allowed to cancel within the part that we're multiplying, but we're not going to be able to cancel anything out with the cosine squared because that's not being multiplied, it's being subtracted. Now over here, tangent times cotangent, everything cancels out. And if everything cancels out, it doesn't equal 0. it equals 1. So we have 1 over cosine squared x minus 1. Now I'm seeing a 1 and I'm seeing a something squared. So that's reminding me of the Pythagorean identities. And I actually want to take my cosine 1 over cosine squared and change it back to what it was at the beginning. Let's change it back to secant squared x minus 1, because that's going to match with our Pythagorean identities a little bit better. The Pythagorean identities were sine squared plus cosine squared equals 1. But right now we have a secant squared. So if I want to get a secant squared, secant's like 1 over cosine. So I want to divide everything by cosine so that I get 1 over cosine. Dividing everything by cosine gives me the identity that tangent squared plus 1 equals secant squared. And this is all off to the side. This isn't part of the problem. This is just me thinking about the problem. I have secant squared minus 1. So secant squared minus 1 equals tangent squared. And that's what we were supposed to get on the other side. So the strategies we used here, we only worked on one side. We're only allowed to work on one side the entire time. We took the more complicated side and made it look like the simpler side. And we did it by changing things into sines and cosines and by using our Pythagorean identities. Let's look at a second example together. This one says problem solving by it, but it's really not problem solving. It's really the same thing that we just did. It says verify the two expressions in the application at the beginning of the lesson are equivalent. That is, verify that 7 times the sine of theta plus 5 times the cosine of theta, all divided by sine theta, cosine theta, really does equal 7 secant theta plus 5 cosecant theta. So there was an application at the beginning of the lesson that tells you what all of that stuff means. It has to do with moving a ladder through a hallway that's 5 feet long in one part and it's 7 feet wide in another part. The application isn't the important thing that we're focusing on. What we really want to focus on is this thing and verifying that it's really true. Pause the video for a second and write down that identity, and then we'll go through how to simplify it. All right, so you should have had a chance to write that problem down. And the strategy we're going to use to simplify it is we're going to start on the more complicated side, which is going to be the left again, and we're going to make it look like the easier side, which is the right. The strategy we're going to use here is we're going to do stuff that's true about fractions. We have 7 sine plus 5 cosine, all divided by something. And I want to take you back to when you are solving equations for y, and if you had 2x plus 10 equaled 4y, so I'm thinking I'm pulling back previous knowledge here. If you divided both sides by 4, when you divide both sides by 4, you're going to divide the 2 by 4, and you're going to divide the 10 by 4. You're going to divide both parts. If you have a binomial divided by something, you divide both parts by 4. The 2x gets divided by 4, and the 10 gets divided by 4. That is going to apply to this, because we have a binomial being divided by something. So what we're going to do is take both parts on the top and divide them by sine theta cosine theta. It'll look like 7 sine theta over sine theta cosine theta plus 5 cosine theta over sine theta cosine theta. And once we have it split up into 2 separate fractions like that, a lot of stuff is going to go away. In the first part, the sines are going to go away, and we're left with 7 divided by cosine. In the second one, the cosines cancel out, and we're left with 5 divided by sine, which seems to be pretty much as far as we can go. And if you're ever stuck, what you want to do is look at what the other side looks like. The other side has a 7, but instead of 7 divided by cosine, it's 7 secant. Well, cosine and secant are reciprocal, so instead of dividing by cosine, that's going to be the same as multiplying by its reciprocal, multiplying by secant. And the same thing in the second part. Dividing by sine is the same as multiplying by the reciprocal. Dividing by something is the same as multiplying by its reciprocal. So it's the same as multiplying by the cosecant. And then we've worked only on one side of the problem, and we ended up with the other side. So it's verified. Let's take a look at the next example. The next example is another verify one. Verify that sine A over cosecant A plus cosine A over secant A equals cosecant squared A minus cotangent squared A is an identity. Pause the video for a minute and write that problem down, and then we'll go through it together. The strategy that we're going to use here is we're going to change everything into sines and cosines. And technically for this problem, you could work on either side, changing it into sines and cosines, and you would get the right answer either way. I want to work on the left, and it's just a personal preference. It's not wrong if you chose to work on the right. It's also going to work, but I'm going to work on the left, and I'm going to change everything into sines and cosines. So I'm going to get sine A over cosecant, that's 1 over sine A. Plus cosine A over secant. Secant is 1 over cosine A. Now I have fractions in a fractions. Those are called compound fractions. And to get rid of it, I'm going to multiply the top and the bottom by the reciprocal. So on this fraction, I'm multiplying the top and the bottom by sine A over 1. And in the other fraction, I'm going to multiply the top and the bottom by cosine A over 1. From the beginning of class, this is the strategy that's called multiplying the expression by something that equals 1. Sine A over 1 over sine A over 1. It's the same thing on the top and the bottom. So I'm multiplying it by something that equals 1. I'm not changing the value. Lots of things canceled out, and you end up with sine squared A plus cosine squared A. And what is sine squared A plus cosine squared A? 1. That's a Pythagorean identity. And here's where we sort of get stuck, because we weren't supposed to prove that it equaled 1. We were supposed to prove that it equals cosecant squared A minus cotangent squared A. But hopefully that thing also equals 1, and then we'll have the same thing on both sides. Now we're not allowed to switch sides in the middle, but what we are allowed to do is look at that side to get some ideas. Let's think about cosecant squared A minus cotangent squared A based on my Pythagorean identity. If I wanted to make this sine squared plus cosine squared equal cotangent squared, let's see, cotangent squared, let's think about my Pythagorean identity. If I want a cotangent squared, I'm going to need to do cosine squared divided by sine squared. So let's take the Pythagorean identity off to the side. This isn't part of my answer. This is just off to the side. I'm going to do sine squared plus cosine squared equals 1, and I'm going to divide everything by sine squared. And I get the other true identity that 1 plus cotangent squared equals cosecant squared. Now this other side of the equation was cosecant squared minus cotangent squared. So what is cosecant squared minus cotangent squared? 1. So I can change this 1 into cosecant squared minus cotangent squared because they're the same. 1 is the same as cosecant squared minus cotangent squared, and that is the other side. So I only worked on one side, but I did look at the other side to get a hint about where I was going on this one. The last example today is very similar but a little bit different. Instead of saying verify, it says find a numerical value of one trig function of x if cotangent x over cosine x equals 2. This time, since we're not verifying, we are allowed to do both things, or things on both sides. Can work on both sides. That's okay. We might not have to, but we are allowed to if we want to. And what this question is asking us to do basically is they're saying this mess, cotangent over cosine equals 2. They want you to simplify this mess and make it so it's just one trig function, like just sine, or just cosine, or just tangent, and they want to know what number it equals. Maybe it's going to equal 2, maybe it's going to equal something else, but we want to simplify the left, make it just one trig function, and figure out what number it would equal, a numerical value. To do that, I can change cotangent into cosine over sine. So now I've got cosine over sine over cosine equals 2. An easy mistake to make would be, I want to multiply by the reciprocal, and you do the reciprocal of the wrong thing. I want to do the reciprocal of what's in the bottom, so I'm going to multiply the top and the bottom by 1 over cosine. That does clear out the fraction within a fraction, and it also actually clears out the cosines on the top. So we've got 1 over sine x equals 2. And we almost have it as just one trig function equals a number. What's the one trig function for 1 over sine x? Cosecant x. So we took the original problem and we simplified it down to find a numerical value for one trig function of x. The homework in this section for you to work on is on page 434, 5 through 11, 14 to 26 even, and 28 to 31 all. And there's a worksheet from section 7.2 to work on also.